Welcome everybody for today's session. My name is Isaac Enchi. A little bit of introduction. I am currently a research scientist at Northern RNA in Calgary, a biotech company. Proud to joining Northern RNA. I was a postdoctoral research associate at Yale University at the Department of Chemistry from September 2021 after my PhD to September 2022. Originally from Ghana, West Africa, immigrated to Canada for my PhD after my bachelor's degree in 2016. And like I said, I moved to the States in 2021 for my postdoc position. Worked with Professor John Vedres for my PhD at University of Alberta as a synthetic organic chemist, and worked with Prof. Scott J. Miller at Yale University, where I'll be sharing a little bit of what I did. The hobbies include soccer, not a professional soccer, just for fun. Anytime I move outside Alberta, I go climbing with friends. I love to try new stuff. So the picture below here was me when I went to Seattle for a conference with a couple of friends, and we went for climbing. And here it's also my soccer team at Canada before I left to the States. What's some of the challenges growing up? Well, you know, in our part of the world, one of the challenge I face, and I believe a lot of people can relate, has to do with the closeness of STEM career in Africa and the difficulty in finding mentors, and hence the reason for my mentorship program and all of the activities I've been doing. How did I overcome this? Well, I took a deliberate attempt to make sure that I do not allow where I come from, the limitations around me, to limit me from accomplishing what I have to. So joining other student groups on campus, LinkedIn, and reaching out to people and other scientists that I think were doing well really helped me. And as pay it forward, I have volunteered on so many, even back home in Ghana, as a chemistry tutor in high school in my community. Then started funding, I funded this Career Enhancement Forum to support brilliant Banidi African students with graduate school and scholarship applications. And that is what I've been doing for a couple of years. I believe in diversity, equity, and inclusion. So, learning from different people, I believe we all have our own strengths and our limitations, and we all have what we bring on board. So, just to show people some of the work I did, and all has to do with organic chemistry, to encourage everybody that it's not rocket science, it's doable, and I enjoy doing it. And if I did it, it means you can, and everybody can, if you have the passion for it. So whilst I was at University of Alberta, I was particularly interested in understanding how some peptides interact with lipid-2 to understand the mechanism of actions and to know how these compounds behave when they come in contact with membranes. And so I was much interested in how do we optimize and come out with a better way of synthesizing some of these complex molecules. Seen here is lipid-2, which is the bacterial cell membrane. I'm not going to go into details, just to show a brief of some of the works that I did. And I was particularly interested in this peptide that is called tridecaptan, which is a gram-negative antimicrobial peptide. And we were trying to understand the mechanism of actions, how these compounds interact in membranes environment. Other works that I also worked on was to use this same lipids to find binding studies with teixobactam, which is also an antibiotics. And other membrane interaction studies were things that I embarked on. So I was basically working on 4 or 5 different projects during my years. And the last 2 projects I did was this small molecule that we call cycloalonapine, where we developed a synthetic method to synthesize pure isomers of these compounds. And prior to COVID, when COVID broke, we had a project where we were interested in synthesizing this by functional ACE2 inhibitors. Unfortunately, I couldn't finish this project before I graduated, so I feel I believe someone it's working on. And then I moved to Yale for my postdoc. I was still interested in antibiotics, antimicrobial compounds. And as many of you know, if you go to the hospital, the last resort antibiotic you'll be given to it's vancomycin. But there is, a family of these glycopeptides, which some of them have improved activity. One of them is teicoplanin. And so when I joined the Miller Group, there had been previous works on how to modify or diversify these types of natural products with the aim of coming up with improved and better, analogs. And the Miller Group, it's well known for its use of peptides as catalysts. And so my project was simple to modify these unique sugar molecules and teicoplanin using some unique catalyst to do site selective modification. Very luckily, we were able to complete this work. We wrote the manuscript before I left, and we're just waiting to submit for publication. So just to give my audience my background, what I do, and currently at Northern RNA, I am working on synthesis of lipids for lipid nanoparticles. So most of you are aware, when the COVID vaccine that you take, they are formulated or encapsulated in nanoparticles. So, these RNAs are mostly unstable. So you have to protect them, and these are protected using lipid nanoparticles. So they formulate these vaccines using lipids, and that is the work I'm currently working on, where we design wide range of available lipids for mRNA works. That's what I'm currently into at Northern RNA. So this is just a brief background and introduction of what I have done in the past for my PhD, my postdoc, and currently what I am doing as a research scientist at Northern RNA. And so I know a lot of us, anytime I speak to people and you hear organic chemistry, I always almost get the same reaction. Oh, it's very difficult. Oh, how do you learn organic chemistry at the PhD level? Oh, I hated organic chemistry in high school, in the university. And we all did, to be honest. We all did. And it's something that bothers me. And now, even if I look back, I personally think inorganic chemistry, analytical chemistry, physical chemistry probably are difficult than organic chemistry from my view. And so I try to let people know that it's not that it's difficult, it's how we are being taught. Even in high school, I remember the first time you get in contact with, organic chemistry is probably in your 3rd year of Corps 3. Most of you from Ghana, perhaps Corps 3s. That's where you start learning these butane, ethane, and all those kind of stuff. And you just confused. And so people have a certain kind of fear for organic chemistry. But it's a branch of chemistry it's very interesting to study. It's very, understandable. It comes with more practice and getting the concepts, and virtually everything surrounding us. You can think of organic chemistry out of it. And so when I speak to university students who think organic chemistry is difficult, I ask them, why do they think it's difficult? And it's just because they don't get the concept of organic chemistry. And that alone, it's a challenge for the first place. So the whole idea is to make people appreciate that organic chemistry is not difficult as we think it is. And it's something we all can learn, understand, and make good use of it. So, like I said, this group or series that I'll be doing has a lot of people signing up. We have first year students, second year students, third year, fourth year, and graduates. And each and every one at each level have our own special needs. Someone in grad school perhaps may not need basic organic chemistry. And so the lectures subsequently will be divided into various groups where we'll be treating topics based on the level. So if you're in first year, you probably want to know first year topics. If you're in second year, perhaps you want to know second year. But the good thing is if you're in your second year and you think you need some refresher courses, you can still join the first year courses. If you're in your third year and you think you need some, refresher courses, you can still join the second year, the first year, and so on. And so if a particular week it's meant for a fourth year topic and you are in your first year organic, first year undergrad, you might not necessarily want to, because you might not, have a feel of what we'll be talking about. But if you're in your fourth year and we are treating some topics which are first year topics, then you can still sit in just to refresh your mind, because organic chemistry is building up. If you don't get the foundations correct, you are not going to appreciate organic chemistry. And so that is how the classes will be. I'll go through the Excel, identify the various groups, and then subsequently from next week, the main target will be the first year, second year, third year, fourth year. And then we will be treating topics, and also people will be doing help sessions. I know Ghana, we probably will call it tutorials, where people can bring either tutorial questions, whatever, past questions or things that they want answers to. We all go through, we work through, and we explain the concept of it so that people will have a feel of it. So today, we wouldn't be wasting much time today. Next week is when the actual course details will start. But I just wanted to introduce people to some of the things and the beauty of organic chemistry. Most of you have read this in textbooks that prior to the discovery of urea, it was believed that organic compounds can only be obtained from living things, right? So people have heard the concept of vitalism, where people prior to the discovery of urea thought that there was a vital force behind this, discovery of organic compounds, and that compounds were only categorized into organic and inorganic, and organic compounds were perceived to have come from living things, whilst inorganic compounds come from inorganic source. Then there was a breakthrough where urea was synthesized from inorganic source, and that was where the whole idea of vitalism started getting off from the chemistry society. And when we say organic chemistry, organic compounds, mostly we define them as carbon-containing compounds. They are either elements, but predominantly carbon-containing compounds. And they can either come from nature or through synthesis. Synthesis in the form that chemists go to the lab, start from scratch with certain starting raw materials and make that same. And natural means from other living things, so either from plants, from sea, animals, soils, so many forms or places where we can. And here I'm just showing you some few of the millions of natural organic compounds. Most of you have heard or know morphine, right? And it's a natural compound. So we isolate it from a natural source. Having said that, now chemists can also synthesize this compound. This paclitaxel is also, organic compound from nature. Penicillin, which we call it the first antibiotics, quote unquote, identified by, one chemist. Oxytocin, sucrose, which mostly we refer as table sugar. All of these compounds are organic compounds from nature. And so chemists draw our inspiration from nature. We look at a compound, we isolate it, and we know how it works. And so we think of, oh, okay, how can we also make this synthetical? This compound, which is ALDH, consists of over 514 amino acids. And so it's hard for you to draw. So you see these ribbons, but all of these are naturally occurring organic molecules, which have biological importance and have been used in diverse areas of our life. So when you think of organic chemistry, you think of carbon-containing compounds. And most organic compounds contains carbon, nitrogen, hydrogen, oxygen, sulfur, some halogens, and so on and so forth, and are used in a very diverse ways. But for you to appreciate organic chemistry, there are basic things you need to grasp. Basic definition, elements, periodic table, the behavior of each atom, how our bonds form, how do they even make these compounds. Now, if I show you this compound in your first year, any of these, and we ask you to make this compound, you probably don't know where to start. But as you progress and you understand how bonds are formed, how reactions take place, you'll be able to break down these compounds, no matter how complex it is, from simple starting material, and then you can build on. I don't recall myself that even in my first year at grad school, I could think of, let's say, if I'm to make penicillin or synthesize penicillin, I could have, because I didn't have much knowledge. But now I can look at penicillin, I can identify some functional groups there, and then I can think of how I can put pieces together to make penicillin in the lab or any other organic molecules. And all comes from understanding the basis of electrons, the basis of atoms, behavior, how elements behave, how reaction take place, what is working behind. And that is what the first year courses or classes will aim at, to let people get the foundation. When I moved to University of Alberta as a PhD student, I had to sit in some advanced undergraduate classes because I was still lacking some concept of organic chemistry. I look at the textbooks that we are using back home, and majority of the topics were not treated. And even if those, some of them were treated, were not treated in details for me to appreciate exactly what I was learning or what was it. And we are fond of memorizing just like that, without understanding what is happening. And that is organic chemistry. You have to understand. And once you understand, you build upon it, and you build upon it, and you build upon it. And no matter how complex a structure, a molecule looks, they all come from the basic organic chemistry, the basic bond formation, the basic electron moving around, the ionic bonds, the covalent, and all those things that we've been taught. That is the foundation. And that is going to be the focus of this entire series of lectures, for us to appreciate and not see organic chemistry as an enemy or as an abstract. I've shown here some natural occurring organic compounds. There are thousands of them. Think of thousands of all the antibiotics, all the compounds which are isolated either from plants. You think of back home, let's say you are sick, your parents go to the farm or, behind the house, get some leaves, boil, you drink, and all of those leaves and medications, root bark, contains organic compounds with specific biological importance. And that is why they work. And each of these reacts differently or in a specific manner when they get in contact with your human body. And by the end of some of these courses, you understand, you know the mechanism of action. Okay, when I take in morphine, what is actually happening? Why does the pain go? Which enzymes, which inhibitors? All of these things you appreciate and you get to know that, oh, okay, that is why. When I take in coffee, why do I not feel sleepy? What is happening? What is contained in coffee? What is the organic compound? And what is it doing in my system? And that is what I love about organic chemistry. To understand, anybody just wake up, go to the store, I want paracetamol, I want, Tylenol, Advil. But you as the organic chemist, you know what is in there, you know the active ingredients, you know the structure. And that is your work. You make these compounds. You know the mechanism of actions. And it's very beautiful studying organic chemistry. It's very beautiful understanding how drugs works and how certain diseases are being cured by taking certain drugs. And it's not rocket science. It's easy, it's simple, and it's doable. You just need to have that open mind, the willingness to learn, and the constant practice and understanding the basic of organic chemistry. And lastly, for today, showing you some compounds that are synthetic, meaning chemists, someone controlling, chemists made this from scratch and synthesized these. I've left this middle compound here, and I want to know from the audience if anybody know what that compound is. Does anyone know what this compound is? The one I'm showing. Who else? Who knows? Well, that's fine. It's okay if, or you can put it in the chat if you know what that compound is. But I intentionally left it out to see how people can identify compounds and see that, oh, this is what it is. But a lot of us take in this compound. Perhaps even today, somebody has taken in, you take in paracetamol, acetaminophen. That is the structure of the drug that you are taking, right? That is what, thank you, Aldo. That was very good for you to get it. Yes, so that is the compound or the active ingredient inside acetaminophen or paracetamol. So we call paracetamol acetaminophen. And all of these are compounds that you can make. Organic chemists, synthetic organic chemists make it and produce, and will have the same reactivity, if not the same, similar reactivity compared to some of the natural source. And a lot of these, most of us know what DDT is, crystal violet. Most of us have heard it. Perhaps you do not know what it is. You think it's something abstract. It's molecules, elements, atoms put together to generate all of these. So this course is going to train you, help you to be able to, in your own way, let's say if you are given a target to, let's say, I ask someone, okay, can you make DDT in the lab? From the basic knowledge you acquired throughout this course, the synthesis, how to break down compounds, how to form certain bonds, you'll be able to form or make some of these compounds just based on the functional groups, the bonds, specific bonds that are there. We'll be going through all of these at the end of these courses, and I'm very hopeful that people will have a different perception of what organic chemistry is, and will learn to appreciate what organic chemists can do, and so on. And I will be bringing guest lecturers, professors, from different universities. I've spoken to a lot of them who will be coming in to treat specific topics. We have, if you are in grad school as an organic chemist, we have some topics called special topics in organic chemistry. And those topics, back home, we don't treat them. Carbohydrate chemistry, lipid chemistry, peptides. I got to know some of this. I had carbohydrates, but I didn't really know details of what it was. So we'll be learning all of these and that special topics in organic chemistry, medicine and pharmaceutical chemistry. How does medicinal chemistry work? Okay, if I give you a compound, what are the modifications that you can do? I want to equip young people to appreciate organic chemistry, to appreciate the beauty of organic chemistry, and to let people know that organic chemistry is not hard as we think it is, but it's a course that anybody who wants to learn and appreciate it can do. So today, I just want to, tease you, entice your appetite for organic chemistry. And then we will start from the scratch for first year students. Second year student will be treating second year topics. Third year student will be treating third year topics. Fourth year student will be treating. And we'll also be doing help sessions or tutorial sessions. Maybe if people will be writing some midterms, you can let me know that, hey, we have some midterms, we have some questions or practice questions that we want us to go through. You can send those questions to me. We dedicate 45 minutes one weekend. We solve, we explain. You don't necessarily have to, some of the things you just have to understand. And then we'll go through so that you can also do well in your exams, in your midterms, and in your quizzes, whatever that is being called. So I'll be looking forward to receiving some of the questions that your lecturers give it to you, the practice questions that you have been handed to, that you have been asked to solve. If you are having challenges, you will send them to me, and then we will say that, okay, this week we are not treating that, we are just solving questions. And I also come with questions, and I will invite people to try and explain or solve the questions. People will be given the access to annotate the screen so that they can walk us through, so that I can also understand the thinking of the student. Okay, why is the student thinking this way? Why is this? So it's going to be fun. We are going to learn a lot. I also plan to bring industry people. You hear organic chemists working in pharmaceutical companies. They are working in the plastic industry. They are working in the cosmetics and all the other areas where organic chemists are valuable. So that you don't think, oh, okay, so well, after I learn organic chemistry, what career is there for me? And I always tell people that, yes, I chose chemistry for my Bachelor of Science degree because I couldn't afford to pay for the medical school program, which every Ghanaian parent wants their son or daughter to be a medical doctor. And since I wasn't financially resourceful, or my parents weren't financially resourceful, chemistry was something that okay, well, if I do chemistry, at least I can make drugs. That is all what I knew. And that was the motivation. And I should say that I have not. And if I'm to go back and to choose any program to read in university, I'll still choose chemistry. I'll still choose biochemistry. I'll still choose molecular biology, chemical biology, some of these pure sciences over the other overhyped science programs that people are not resourceful, are still forcing their parents. You can be organic chemistry and still go to med school and go to pharmacy school. I could have applied to a PhD program in pharmacy with my chemistry. So the whole world is open for you. and most of you who are aware and follow the news, you can think of the numerous biotechs that are coming up. You can think of all the startup companies focusing on drug discovery, focusing on curing disease. And there is a whole lot of things you can do if you study chemistry, either chemical biologist, organic chemist, analytical chemist, computational chemist, and so on and so forth. So please don't be fixated with medicine is good. I mean, I have no problem with it. But if your parents are not financially able to take you to med school, you don't want, I for the past couple of weeks, I've been reached out to, oh, Isaac, this student had 8 A's. They don't have money. Can you help that raise funds? And I tell them, it's not about helping raising funds. That person needs constant supply of money throughout med school for her to be successful. But there are many streams and opportunities. And I don't know some of you who knows this girl, Francisca, that Kita girl, you know, when she was applying for her med school program, you know, they reached out. I was talking to her to help her understand. And I could see that this is someone who can do extremely also better in other fields, in other discovery. So please, there are a lot of things you can do with reading chemistry, reading organic chemistry, analytical chemistry, environmental chemistry, and so on and so forth. So I want you to appreciate the beauty of organic chemistry, what you can do, the things you can think of. And I have no doubt some of you might be the next, you know, scientists discovering the novel cure for certain diseases that people cannot think of. And that is what you should see and dream of. So I'll be ending here, and then I'll be giving opportunity for people to ask questions, to find out, and also to get to know the special needs of people. I'll be creating an Excel where some of these questions will be asked and people can find, so I can also identify the needs. So please, I'll stop sharing the screen and you can unmute yourself to ask question, your challenge, your difficulty, what you aim to achieve in these courses, and so to guide me as well when putting in